factor. Alright students, now that we're at the board, let's talk about scale drawings and scale factor. First we're going to look at the scale factor calculation. Now this is important you get this down right away. When we're looking at this, basically going to give us a proportion. You have the scale model over the actual object, and it should be the same on both sides. What I mean by that is you're going to keep the units the same. We're going to be relating two different sets of units to find what we're looking for. So if you have, for example, inches over feet, on the other side of the proportion, you're going to have inches over feet. Alright, now let's look at question number 1. In a scale drawing of a painting, 1 centimeter represents 8 inches. So you see the painting of the Mona Lisa here, and it has a scale of 1 centimeter to 8 inches. If you remember, we're talking about scale factor. What this means is we have a representation of two different sets of units, one representing the scale drawing and the other the actual painting. And if you also recall, it's scale model over actual object. That's how we're going to keep these things in line. So we're going to take that scale factor and we're going to write it as a fraction. Then we'll continue to make it a proportion by keeping the same units on top and on bottom of the second fraction. Now we can answer the question. The height of the real painting is 48 inches. What is the height of the painting in the scale drawing? Well, since the 48 inches is the actual object, we're going to put it down on the bottom where the inches are. And then the part we're looking for is the amount in the scale drawing. Now we do like we always do with proportions. We're going to multiply in the diagonal direction and then divide by the only other number we have left. That gives us 48 divided by 8, which is 6 centimeters. Now let's do this for the second part. In the scale drawing, the length of the painting is 4 centimeters. What is the length of the real painting? So again, since this is the scale drawing, we'll put that 4 centimeters up on top where the centimeters are because that's the scale model. Then of course the piece we're looking for is the actual painting. So again, we'll multiply diagonally and then divide by the only number we have left. And 4 times 8 is 32. So the actual length of the painting is 32 inches. Alright, on to question 2. In a scale drawing of a house, 1 inch represents 10 feet. So we're going to take this scale factor and put it into a fraction. Then we'll make it a proportion by making it equal to another fraction, and again keeping the units the same on top and on bottom. Now we can answer the questions and put in the pieces we need. The length of the real house is 40 feet. What is the length of the house in the scale drawing? Well, since 40 is the real house length, we're going to put on the bottom where the feet are. And of course the piece we're looking for is the scale length. So we'll multiply diagonally and then divide by the number we have left. So 40 times 1 divided by 10 is going to be 4. That means that the length of the scale drawing of the house is 4 inches. Then in the scale drawing, the height of the house is 6 inches. What is the height of the real house? So again, the height of the house in the scale drawing is 6 inches, so we'll put 6 on top where the inches are. And what we're looking for is the height of the real house, so that becomes our x. So 6 times 10, and then divided by 1 will leave us with 60. Alright, now we have question number 3. In a scale model of a table, 1 centimeter represents 7 inches. So again, we'll take our scale factor and turn it into a fraction, then make it into a proportion by keeping the units the same. We can answer the questions. In the scale model, the length of the table is 6 centimeters. What's the length of the real table? So since the scale model is 6 centimeters, it becomes 6 centimeters up on top, and x goes down on the bottom with the inches. And like we've been doing, 6 times 7 diagonally, then divide by 1 leaves us 42 inches. Then part B, the height of the real table is 35 inches. What is the height of the table in the scale model? The height of the real table is 35 inches, so it goes on the bottom with the inches. Then we multiply diagonally, then divide. 35 divided by 7 gives us 5 centimeters for the scale drawing. Question number 4. The table below gives us the dimensions of a statue and the scale drawing of the statue. Find the scale factor of the drawing. The scale factor to get to the drawing from the statue. This is very important. They did not give us the scale factor this time. So we have to remember what we learned right at the very beginning. that the scale model goes over the actual object. In this case means the drawing over the statue. So we've already got the measurements for the height and the length, and they should be exactly the same if they're a true scale model. So let's see what they got. So we have the drawing over the statue would give us 9/72. And it says they want us to answer in a fraction in its simplest form. So we have to reduce this fraction by dividing top and bottom by 9, which gives us 1/8. Now if we do this for the length as well, we have 64 and 8. So 8/64. And again, if we reduce this fraction by dividing top and bottom by 8, we get 1/8. So that means that the scale factor is 1/8. Let's try another one here on question 5. The table below gives the dimensions of a bridge and a scale model of the bridge. So again, remember that the scale model goes above the actual object. So in this case, we have the model over the bridge. So we have our measurements here, 6 for the model, 21 for the bridge. Gives us 6/21. Now we reduce that fraction, it gives us 2/7. We'll try it again for the height. We have 8/28, which reduces also to 2/7. And for the last one, for the length, we have 10/35, which again goes to 2/7, which means that the scale factor is 2/7. Question 6. The table below gives dimensions of a sculpture and a scale model of the sculpture. Alright, once again, scale model goes above the actual object. So we have the model over the sculpture. Now this one's a little different, a little tricky from the last question I showed you because the model's on the right side instead of the left side. Don't let that confuse you. Remember which one's the actual item and which one is the scale model of the item. So for the length, we have 7/28 because the model is 7 and the sculpture is 28. When we reduce that fraction, we get 1/4. Then for the width, we have 5/20, which is also 1/4, and 8/32, which is also going to reduce to 1/4, meaning that our scale factor is 1/4. Alright, question 7, we have a scale drawing for a plot of land is shown. In the drawing, 3 centimeters represents 4 meters. Assuming the backyard is rectangular, find the area of the real backyard. Remember, our scale factor is right here. 3 centimeters represents 4 meters. So the scale model is over the actual object, meaning the drawing goes over the backyard. Now this one's a little different because we have to get both of these measurements, not just one like we've done in the past. So first let's start looking at the length. We always begin with our scale factor because we know that to be true. Then we look at what the actual and what the drawing is. In this case we have the drawing, which is 6 centimeters. So once we do the proportion, 6 times 4, then divide by 3, we get a length of 8 meters. Then we're going to look at the width. Again, we start with our scale factor, and the width of the backyard is 9 centimeters. Then we multiply and divide, and we get 12 meters. So to find the area, we have to multiply the length times the width, and we end up with 8 meters times 12 meters, which gives us 96 meters squared, because an area is always square units. Question 8, we have another one just like number 7. We have this scale drawing of a restaurant as shown below. In the drawing, 1 centimeter represents 3 meters. And assuming the dining hall is rectangular, find the area of the real dining hall. So once again, we have the length, and we're going to start with the scale factor. 1 centimeter over 3 meters. In the picture, the dining hall is 4 centimeters long. So we multiply and divide, and we end up with a length of 12 meters. Then we look at the width, and the width is going to start with the scale factor again. Then we have 3 centimeters in width, so we multiply and we divide, and we end up with 9 meters for the actual width. Now, to find the area, we multiply the two together, and we get 108 meters squared. Question 9. The figure below was made with a scale of 1 unit equaling 6 yards. We want to draw the figure with a new scale of 1 unit equaling 3 yards. So the first thing we should do is see how many units are in each side of this shape, which is a square. So if you count with me, each side is 5 units. So we're going to use our scale factor. 1 unit per 6 yards, and this picture here has 5 units. So what it's going to actually equal out to when you multiply and divide is that's actually 30 yards, and that would be the same for all 4 sides. On the new shape, we're going to be using a scale of 1 unit to 3 yards. So we take that same 30 yards that we found in the other, 30 times 1 divided by 3. That means now we're going to have 10 units on each side. So our shape should look something like this. Alright, last question. The figure below was made with a scale of 1 unit to 6 centimeters. Draw the figure with a new scale of 1 unit to 2 centimeters. Now this one's a little different than the previous one because it's not a square. There are two different numbers for length and width. So we'll start by looking at the width, which is 2 units. There's 2 boxes across. So we take the scale factor of 1 unit to 6 centimeters, and we put in our 2 units, and then when we multiply and divide, we get 12 centimeters for that width. Now for the length, we have 3 units because there's 3 boxes going up or down. So we take our same scale factor, put in the 3 units, and our length is now 18 centimeters. So if we take those two numbers and we realize that each box is 2 centimeters, that's going to mean that the length should be 9 units across and the width should be 12 centimeters. So that means it's going to be 6 boxes. So your shape should look something like this.
It's